Yeah, good evening, everyone. So I think we can start with our session. So we'll be discussing object-oriented concepts in Python first. So we'll take around spend around 1 hour on this topic. So in between, if you have any doubts, you can use the chat window. I'll be monitoring that. Uh, or you can directly unmute and ask it. Okay, you can interrupt me at any time in case you need me to go slow, go fast, or you need to explain something. So basically, this will be our agenda for today. So basically, we will be seeing the object-oriented programming concepts. So I will come to details like what we mean by an object, things and all. So we'll be basically seeing it with relation to what is called the 4 pillars of object-oriented programming. So the basically abstraction, encapsulation, inheritance, polymorphism. So these 4 terms you get to know. So we will try to go into details of what each term means, how to use that, how it is applied in Python, things like that. So this is applicable to any object-oriented programming language, whether it be Java, C++, or any other object-oriented programming. These 4 principles form the backbone. So abstraction, encapsulation, inheritance, and polymorphism. So we will structure like we will go through each of these and see. We will build upon from examples starting from scratch. Finally, we will try to build something that is like a concrete class. So that way we will proceed. So, okay, so we need not have the table of contents here, right? So at any time if required, we will come into that. So I think I am using Collab here. I think it is similar to our Jupyter notebook we are running locally in our PC. The Collab will run it in the cloud. So basically you will need a Google account for that. So that you can sync it with your drive and you can use the resources from the Google platform itself for your notebook. So you can access it from any time. Otherwise, you will have to like mail your notebooks and all. So this is called the Collab or Collaboratory, which is provided by Google. Okay, so basically we will start now. So what is object-oriented programming? So here 3 terms programming you already know. Then object-oriented. So that means from the word meaning you can know that it is based on objects. So what is an object? So what is an object is like if we see our real world around us, all of us are objects only, right? You are a person. So person can be treated as an object. And or in the more common sense, if I take a pen or a pencil, so that is an object. So similar to that, coming to real programming, we want to simulate entries which are similar to our real world. So basically we are like telling that, okay, this corresponding object or this entity corresponds to a pen in real world. So I will create something called an object called a pen. So things like that are will come under object-oriented programming. So I am basically trying to think of real world things as objects or entities in my program. So what does an object contains? So object when you implement it in any programming language, that will basically contain a group of data attributes with functions or methods. So they basically have a pen. A pen will have characters like it will have a ink, right, or a dot pen or ink pen. So that will be like a characteristic of the pen. Then what make it is, either it is Reynolds or things like that. Then or and a set of methods, right? So what are the methods or operations that you can do with a pen? You can write with a pen. So that is a method. And if it is an ink pen, you can fill ink to that. That is a method. Or you can extract ink out of that. So those things will come under methods. So if you see a pen, so this data attributes will be like a type of the pen, make of the pen, things like that. And the methods will be like writing, then filling ink or removing ink, things like that. So that way, everything in an object-oriented programming language are centered around objects. And some of the popular object-oriented languages are Java, Python, C++, etc. And typically, I have stressing the word typically here, object-oriented programming languages are class-based, which means that a class will define like a map or a template, and objects are like members or instances of that particular class. So class is like a blueprint and objects are like instances of that class. So why I told it is typically because in programming languages like Python or Java, this is true. But if you see C++, you can actually write a C++ program similar to a C program, which has not even a single class in it. So that is why I have used typically here. But even then, C++ is considered as an object-oriented language only. And we can have multiple objects correspond to the same class. Like if I have a class called pen, I can have an object corresponding to a Reynolds pen or Automac pen, things like that, or even multiple Reynolds pens. So that is what I mean by this statement. Multiple independent objects may be instantiated or represented from the same class, and they may interact with each other also. Suppose one pen, my ink is almost about to be over. I want to take some ink out of this and fill it in the other pen. So that way we can tell that two pens interact. So similar way we can implement in programs also. We can have the multiple objects to interact with each other. So now the key terms that we saw just now, object is an instance of a class. Class is a blueprint. You instantiate classes to create objects of that class, and objects of a class can interact with each other as well as with objects of other classes. So now we will come to our actual, because I will be using these terms throughout my session. That's why I told in detail what you mean by each of these. So we will see 4 pillars of object-oriented programming in detail. So I put a simple reference here. So I will share the notebook. You can go through that. OK, just for extra reading. And during the course, I have used additional references also. So that links are given at the appropriate places. If you need more details, you can always refer them. So again, you keep this in your mind. The 4 pillars of object-oriented programming: abstraction, encapsulation, inheritance, polymorphism. This is like a standard interview question, where if you use tell Python, next thing will be, is Python an object-oriented language? The next thing will be, OK, what are the 4 pillars of object-oriented programming or main principles of object-oriented programming, things like that. So answer is these 4. So we will come into detail through each of these. First one is abstraction. So what is abstraction? So as we told earlier, we have a pen. So a pen, actually, if you see a pen has a refill or a ink pen has a nib or something, then it is encapsulated in a body, right? And it has some mechanical components to insert it. Then it has a cap. So, but when I want to write, I just buy a pen for 5 rupees or 2 rupees or something from, or 10 rupees, whatever it is from the shop. I just use that, right? I don't need to know about the intricate details like how a pen is manufactured or what, how they are putting ink into the refill, things like that, details like that I don't need to worry about. I just need to buy a pen, I can directly use it. So that is what we mean by abstraction. So hiding unnecessary details from the user. The user of a pen only wants to use that. He does not want to know is it made with biodegradable things or is it made with plastic or the manufacturing process behind it. All those unnecessary details he need not worry about. For another example, you consider like we are ordering a food on app like Zomato, and we can there choose food items, restaurant, and we will make payment and we will get it delivered at the doorsteps. So we need not worry about whatever is happening inside the process. What like how the order is forwarded to the restaurant, how delivery boy is allotted, or technical implementation details, or what software they are using to implement this app, or which database they are using at backend. So all these nitty-gritty details you don't need to worry about. So that is another case of an abstraction. You only need to like work at a top level, directly give an order, and get it delivered. Make payment, get it delivered. That much only you need to worry about. So that is what we mean by abstraction. So you are provided a top layer abstraction that lets you order without worrying about any of this process. So same way, if you want to define a human class to represent any of us or all of us, right? So that we will be using this example throughout, we will be building upon it sequentially. So let's build a class called human. So currently I am not defining anything inside this. So we have already seen in previous sessions, if you don't want to do anything inside anything function or something, we will use the keyword pass. So 2 keywords are used here. One is class, which is used to define a class, and second one is pass, which is used to inform the Python interpreter that I need not do anything for this particular class. That if this class is created, you just create a dummy object, right? So then what will happen? So then we have seen that help will give me the details of that particular thing. So if we type help for that our human example, it will tell that it will give a help on class module in main. It will tell that class human. Inside bracket, it is telling that it is type of built-in object. So we will see what it means inside this bracket slightly later. Then data descriptors defined here. By default, two descriptors are dictionary and a reference. Two things are this I did not create. As you can see here, I did not create anything here, right? But something came inside bracket here, and inside the two methods came. So which I did not create. So okay, we got something here. So we can just try to see what an object is. So if you see an object, what the interpreter is telling me that it is a most base type. So when we come into inheritance, you will get more details into this. So basically, whatever class we try to create in Python, if we don't specify any parent for that, that will be created as a subclass of object. So that is why, even though we didn't specify any inheritance here, it came as built-in stored object, a subclass of or a child class of that particular object. So what a child class is and all, we will come into details later. So this you just keep in mind that object human is inherited from object or any class. Any class you create in Python, other the way with where you don't explicitly specify something within brackets here, that will be inherited from the base class called object. Okay, now I want to create some objects. I created just a class. As you saw earlier, it is a blueprint. Now I want to create an object. So I create, this is how I create an object. So here I am creating an object with the name Arun, my name itself, and then I am telling that, okay, Arun is of the class human. So I am creating a human named object of the class human, which is the object is named Arun here. Then I will just try out 2-3 commands. All these commands we saw in previous classes. I will see the type of Arun. Then I will check whether Arun is an instance of human class, as well as I will check whether Arun is an instance of object class. So you guys can just see our chat. What will be the output of this? What will I get for this? Each instance, last two statements, whether I will get true, false, nothing, none. What I will get? Okay, I will assume you told the true. Okay, so type of Arun is like main defined class human, and it is an instance of human class as well as an instance of object class. This we saw earlier, like human is inherited from object, so it will be by default an instance of both classes. Now we